Today we're going to be looking at the TDA2822M integrated circuit. It's a tiny little 8-pin chip, same size as the LM386, except this is a stereo op-amp. So it's got two inputs, two outputs, as opposed to the LM386's one input and one output. It's approximately, as the datasheet says, it's 1 watt per channel into, I think it's an 8 ohm load. Datasheet, by the way, is there's a link to that in the description. Now, so far on this circuit, I've got a LM317 voltage regulator, linear voltage regulator, because I spoke to JohnAudioTech, and obviously I've looked on YouTube, see that JohnAudioTech had done a video about the TDA2822M, and I got in contact with him and I asked him what was the best voltage to run the chip on, because I noticed in his video he did it at 9 volts. However, on the datasheet it says anywhere between 1.8 and 15 volts. Now, after a brief conversation with him, he informed me that if I'm running into a 8 ohm load, 8 ohm resistive load, that I don't really want to go above 9 volts, hence the LM317 linear voltage regulator. Now, in this part of the circuit there is 1, 2, 3, 4, 5, 6, 7, 8 components. That's basically 2 diodes, 3 capacitors, the LM317 and 2 resistors. If you're interested in the LM317 and how to set it up and use it in your circuit to regulate a voltage, I suggest you look at the datasheet. It is really simple. I mean, basically it's 2 resistors and the LM317, and the 2 resistors set the output voltage. So I've got this set at, well, I've got a 100 ohm resistor and a, I think it was 620 ohm resistor or 600 ohm resistor, one of the two. Now, it kind of uses a voltage divider. If you put 12 volts into the LM317, it will put 1.25 volts out of the voltage out pin. Now, there's the adjust pin. If you set the resistor on the adjust pin and a resistor on the voltage out pin, you can adjust that voltage from anywhere from, I think it was 1.25 to 30 something volts in the datasheet, I'm sure I read. However, I only need 9 volts. And the reason I need 9 volts is because this amplifier is going to be run from 3 mobile phone batteries. I realise this one's a lithium polymer cell, however, just for testing purposes I'm using this. I've ordered 2 more of these Arcos batteries, and the reason I've ordered 2 more of those is because they're 4,000 milliamp hour batteries. It says on it 3.7 volts, 4,000 milliamp hour, 14.8 watt hours. So they are very good batteries, high capacity batteries. I mean, the mobile phone I took that out of before it actually got drenched and broke, I had to charge that phone maybe once every 10 weeks. Sometimes it goes as long as 12 weeks. So, you know, it's a very high capacity battery designed for a very low power phone. Now, the circuit that we're going to use this in isn't really a high power circuit either. So, my thinking behind this, using these 3 of these batteries, is that I'm going to get a very good battery life. So for now, just for now, I haven't bothered removing the charge protection circuit off the top of the battery. All I've done is soldered 2 wires to the battery terminals, and we're going to wire those 3 batteries up in series, run it through the LM317, and then drop the voltage down to 9 volts or thereabouts. Sorry, for the TDA2822M. I will do a video on the LM317 at some point in the future. However, if you're interested in it, I suggest you check the datasheet out. It's really simple to use. I mean, really simple to use. There's even, if you're not very good at the maths and you want to work out the resistor values to get a particular voltage, you just type in on Google LM317 calculator, and you'll find something that will be able to help you very easily. Anyway, back to the TDA2822M. I've soldered the headphone jack onto the Vero board. which is how we're going to get our input signal for the amplifier. I've got this dual gang 100k potentiometer, which we're going to put onto the Vero board. So I'll do that now, solder it on, and then I'll come back to you and I'll explain a little bit more about the TDA2822M circuit. So there we go, I have soldered the 100k potentiometer onto the Vero board. Now these two wires, because it would have been very difficult to actually access, if I'd soldered the potentiometer in, sorry, it would have been very difficult to access between the two gangs of the potentiometer to wire up the inputs. I decided I'd do it before I actually soldered the potentiometer in. So we've got an input from the headphone jack there, and this one will be an output to the TDA2822M. I don't need to do it for the gang at the rear because I can use the tracks on the bottom of the Vero board for that, but what I shall have to do here is just sever the tracks on those three tracks there, and all I'll do is I'll just get a Stanley knife or something similar, screwdriver, Stanley knife, whatever, and I'll just literally scrape the copper off, and then there'll be no connection between that pin and that pin and that pin and that pin, and we will have proper left and right separation. So I don't know whether you can see that, however I have severed the track between that pin and that pin and that pin and that pin. This one's going to be the earth, so it doesn't need to be severed. However, this is going to be a left channel input and then an output, or the other way around, sorry, the left channel, in the inputs of the centre pins, the outputs of the pins on the left there. We've got left input, right input, or whichever way around I do it. Now I'll just grab the multimeter and set it to continuity testing mode, and we'll just double check that I've done a good enough job of severing those tracks. So we'll just probe here and here, and here and here. Brilliant, no beep, so we know we've done a good enough job. So what I'm going to do now is I am going to just sort out the ground between the headphone socket, the potentiometer, and then we're going to ground it to the negative rail where the power comes in, which obviously is going to be this rail here. So I will run a wire from the ground on the headphone socket, I'll run it from there across to the potentiometer, and then from the potentiometer across again. I'll just get some wires, trim them to the correct length to go from there to there, and then from there to there. So there we have a wire going from the ground of the input to the ground on the potentiometer. The ground on the potentiometer is also linked to the power supply ground. I shall now solder those on. So let's see if we can't do this. If I just get one part of each wire soldered, and we'll be half of that wire soldered, half of this one soldered. One more contact that needs soldering. Now we can trim. There's my decent wire snips gone. Now we can trim all these wires down, poking through the back of the circuit board. Obviously this Vero board is a bit on the large side for this circuit, so once the circuit is complete I shall take a hacksaw and I'll hacksaw down there. It just makes it a bit neater and it will fit inside the speaker enclosure better. Take the legs off the LM3 as well. So there we go. That part of the circuit is now complete. Time for me to pull up the datasheet on the computer, find the circuit diagram that I drew, and then we'll carry on building it. I've connected up the left input and the right input to the potentiometer using the red, white and the blue wire there is for the ground. This green wire is coming off for either, I don't know if it's the left or the right channel, I can't remember which, but that green wire will connect to the TDA2822M, which we are going to now find a place for somewhere on this circuit board. Now obviously I can put it anywhere I like, just like that. I don't know whether I'm going to decide on that as its final place, because I have got to get some capacitors in there as well on the inputs, but I'll grab the circuit diagram that I've drawn. I'll double check just how much space I'm going to need on the board for my capacitors, etc. I'll probably put the capacitors in somewhere on the Vero board, just double check I've got enough space to complete the circuit. I'll grab the capacitors, check the circuit diagram, put everything on the circuit board, double check how much space I need, and then I'll get back to you. So the first part of the circuit we're going to deal with is the input from the potentiometer to the TDA2822M. And for this part of the circuit I'm going to need two 10k resistors, two 100 microfarad capacitors. So I've got two 100 microfarad capacitors there, and we've got two 10k resistors here. Now on this integrated circuit, pins 1 and 3 are your outputs to your speakers, pin 2 is VCC, pin 4 is ground, and then 5, 6, 7 and 8 are your inputs. So pin 5 is a negative input, 6 is a positive input, 7 is a positive input and 8 is a negative input. What we need to do is grab the capacitors and the resistors, and we need to put those into the circuit in the input. So the resistors go from the left and right input to ground, and the capacitors go from the negative left and right input to ground. So I'll put those into the circuit, solder this in. So I'm going to solder the TDA2822M onto this Vero board now. And I'm going to grab a little bit of sticky tape and just tape it to the board so it doesn't fall out when I turn it upside down. A bit of tape. Crazy what gaffer tape comes in handy for. Look. There we go. So now I can solder all 8 of those pins onto the Vero board. I'll come back to that one in a second. Nice, we'll just sort this solder bridge out now. One left to solder now. I'm attacking it from a different angle, see if we can accomplish what we need to this way. Perfect. Okay, now I obviously have to sever these tracks here so that pins 1 and 8 and what have you don't make contact. So I'm taking a little bit of solder off this pin here. Easier said than done, especially when the kids have broken my desoldering pump. There we go. I'll now sever those, take the gaffer tape off, and then we'll carry on with the rest of the circuit. So the technique that I use on the Vero board for severing the tracks, take a screwdriver, and basically all I'm trying to do is take some of the copper off so that there is no electrical connectivity between that pin and that pin and that pin and that pin. You can actually buy a special tool for this, but I don't particularly want to spend the £8 or £9 on the tool when a 25p Stanley knife blade will do the trick. Now obviously, as before, when I did sever those tracks there, the best thing to do to check that you've actually got no electrical connectivity between the 2 points on the circuit board is to get your continuity tester out and just probe either side of the integrated circuit chip. And obviously you have to be careful not to cut any of the tracks that you're going to want to keep. If you do, it's not a big problem. You can always put a solder bridge across the two, but it's just better not to. So if you can see there, I've taken maybe 1.5, maybe 2 mil of the copper off between all 4 pins of the integrated circuit. And just to double check, we should grab the multimeter and we'll just check. Provided we get no beeps here, we will be fine. So there we go. Those connections are severed, and we carry on building the rest of the circuit now. I have noticed on the datasheet that the way this chip's been designed, ST Microelectronics did a very good job actually, because pins 5 and 8 are the negative inputs. Now you have to put capacitors on those, so the way the chip has been designed is actually quite clever, because of the pin numbers that they've chosen, it makes it easy to put your capacitors in to get them, the ground out of the way, the rest of the circuit. It's actually very clever. So there's one capacitor. Here is the other capacitor. I think I need to move it up a little bit, but yeah, you get the picture. There we go. So there's the 2 capacitors going from the negative input to ground. I'll get the gaffer tape back out, solder those. So this just makes it easy to solder the components. It means I can do more than one component in one go with the soldering iron. But we'll get those soldered. I've just done one leg of each capacitor for now. Now I'll take the gaffer tape off. Be careful not to pull the capacitors off along with it, because it's very, very strong. And I'll just make sure that they're pushed down onto the circuit board properly as I solder the other leg onto the board. Now I would usually suggest that to prototype something like this in a breadboard before you actually build it. Today I've thrown caution to the wind and I'm not going to bother doing that. We're just going straight onto the Vero board. If need be, I can always desolder it. Now for the positive side of the inputs. When I chose the place for the TDA2822M chip, I tried to choose somewhere on the board where I wasn't going to be having to run wires from one connection to another connection, etc. All I have to do now is connect up this green wire to pin 6, solder that in, and then the other connection that goes to pin 7 is already on the same track as the output for the potentiometer. So then all I need to do then is, before each pin, is put a 10k resistor to ground. We're going to put the resistor from there to ground, and the same thing on this channel. And I think I'm just going to ground them to the same place I'm going to ground the capacitors, and then obviously we will have to connect the capacitors up to a ground. I will turn the circuit board over and just double check, because I don't want to have to make any more connections than I really need to. So if I get one leg of the resistor, now these resistors aren't going to slide all the way to the surface of the circuit board, but they're close enough, and that will do. Chuck that there to stop it from falling out. And I'll turn it upside down. I don't like doing it. I like to be nice and neat, but you can't always be nice and neat, can you? So that is the input side of the circuit complete. All we need to do now is ground the negative legs of the resistors, the capacitors. And as far as we do that, then the resistors are also grounded. So I'm going to take a couple of wires and I'm going to run them from the same track over to the ground, just like that. And then obviously I need to do the same for that capacitor, and then we'll get those soldered on. And we'll use the same trick again to stop the wires falling out. And the reason I use gaffer tape and not insulation tape is because the gaffer tape stays stickier for a lot longer than the insulation tape. So I shall solder those now. Do the one next to the chip last. The input stage of this integrated circuit is now complete, and we just need to concentrate on the output stage. Output stage is going to be more or less the same, a couple of capacitors, and then obviously left and right outputs, and then we've got pin 2 and pin 4, which are VCC and ground, which need connecting up, and after that connect the speaker up and we'll try it out. So just to recap, the two capacitors on the input stage were 100 microfarad. I used 100 microfarad, 25 volts. Now the ones I'm going to use on the output stage are these little, I think they're nylon or nylon, possibly, I think they're ceramic, and I think they're nylon capacitors. But what I'm going to use is these little ceramic capacitors, provided I have got the ones of the correct value. If not, then I will use the nylon ones. On pin 2 we need a 10 microfarad capacitor to ground. So we would connect the positive wire somewhere here, then have a capacitor before the power reaches the TDA2822M chip. I'm just going to double check the data sheet, double check the circuit diagram that I've drawn, write down the capacitor values, and then search through my big box full of capacitors and see if we can find the correct values. So on the output stage we need two 470 microfarad capacitors. We need two 0.1 microfarad capacitors, and it also says two 4.7 ohm resistors. I'm going to have to resort to grabbing the multimeter and spending 15 or 20 minutes probing at circuit boards to find some resistors of a suitable value. I'm going to go and scour other circuit boards for some maybe 10 ohm resistors. 10 ohms would be perfect, I would have thought. So I don't know whether I'm going to be able to find ordinary resistors or whether I'm going to get surface mount resistors. I'm not 100% sure. So after a bit of hunting around, I've got this little circuit board here, which is actually out of a compact fluorescent light bulb. A really good source of capacitors, actually. These are capacitors, diodes, toroidal coils. Anyway, there are some 10 ohm resistors, surface mount resistors on the bottom of this, so I shall desolder those and we'll incorporate those into the circuit. So on the output stage, coming from pin 1 and pin 3, there are two 470 microfarad capacitors. So we will put those in the circuit board right now. So pins 1 and pins 3. You shall have to go like that. But before I do this, obviously, because it's going to be hard to connect it up afterwards, I'm going to connect pin 4 to ground. Pin 4 to ground. And pin 4 to ground. Just like that. So that's pin 4 to a ground. Back to these capacitors. So pins 1 and 3. And we shall solder that on now. And again, the track will need severing between the two legs of the capacitor. Can't do that straight away. I shall solder the other capacitor in and then I shall do that. So that's pin 1. Now we need to do the same for pin 3. Get that one soldered on. And now I shall grab the Stanley knife and break the tracks between the two legs of the capacitors. So there you go. I don't know whether you can see that, but I've just scraped a little bit of the copper off between each of the capacitor legs on pins 1 and 3. Just double check it with the continuity meter. You can get other types of Vero board where you don't actually have to do this. However, my local Mappling store doesn't sell it, so there we go. There is no continuity on those two tracks, so that's perfect. Next there is a 0.1 microfarad capacitor for both the left and the right output channels. So we will deal with those now. I've got those there, ceramic capacitors, 0.1. Or I've got these nylon ones, they say 0.1 J63 on. I'm just going to double check that they are 0.1 microfarad capacitors on the internet. I'll just go and Google that quick. I'm fairly confident they are, however it doesn't hurt to double check. Yeah, after a quick Google search, they say, I don't know whether you can see that. Anyway, it says 0.1 J63 on there, and they are 100 nanofarad, which is 0.1 microfarad. So then we need one of these on each of the outputs. So this will be another job for the gaffer tape. Double check we've got them on the right place. We'll put one a bit closer up now and one there, and then we will grab the gaffer tape, hold those into place while I solder them on. And again, I will have to sever the track between the two legs of these capacitors. So I've severed those two tracks, and between the negative leg of that capacitor and that capacitor, and before those capacitors, I will draw I will solder rather 2 wires, and they will go to the positive connections of the speakers. And then it's a simple case of turning the circuit board back over, sticking the 2 surface mount resistors on, and then connecting both of these to a ground. And then we just need to connect a positive up with a capacitor to the VCC pin, which is pin 2, and then this circuit will be complete. I'll grab a couple of wires for my speaker outputs now, and we'll get those soldered on. Okay, so this wire is actually really thin gauge wire, however it's got decent insulation on, and I can also differentiate between the left and the right channel because one's got a red stripe on. So just makes things easier for me when I come to wire the speakers up. Okay. I think I'll do this 1 wire at a time. So there we have our speaker outputs. So now it's just time for the resistors to ground. And I hate surface mount components because I have to get that into the circuit connected up. So to prepare the Vero board for the surface mount component, what I am going to have to do, I'm going to have to sever a piece of this track so that the resistor actually does its job and resists current flow. However, they are very, very small surface mount components. They're not the smallest you can get, but they're still rather small. I just need to take a tiny bit of the track off back of this Vero board, which is easier said than done. And yes, I know I'm pushing against the sharp part of the blade, however the back piece of the blade is perfect for doing the job that I need. I'll grab the multimeter and we'll just use the continuity tester on there. Just double check. Fairly sure I've done what I need to. Perfect. Now with surface mount components, I find the easiest way to do it, to be honest, is just to put a tiny bit of solder onto one part of the track like that. If I can get it to sit in the right place, this little blob of solder, without it bridging the gap that I made in the track. And then we'll put a tiny bit more there. Down a bit, okay. Now, because I removed these from something else, there is actually a little bit of solder on the resistor already. So let's attempt this. If you don't like surface mount components, let me know in the comments because I hate them. Okay, this is where I could really do with something to hold the surface mount component. And we'll just try heating this solder up. pushing the component slightly to the right. Didn't quite work as I wanted it to, but there we go. Okay, so hopefully that's one side connected up sufficiently. And then theoretically all I need to do now is melt the solder here and drag it back this way. And that should be sufficient. Now we will just test the resistance from here to here. And yeah, we're fine. 10.4 ohms. Okay, so now we'll just repeat that process for the second resistor, and then all we have to do is ground that track to there, and ground that track to there, and then we'll concentrate on the VCC pin and putting the capacitor on there and connecting it all up. Put another break in the track on the Vero board, and I shall attempt the same process again. And again, you will just check the resistance to make sure that it's connected up properly. There we go, 10.4. What was this one? Was this 10.4 as well? 10.2. Okay, so there we go. There's the two resistors in. Now I just need to ground both of these tracks to there, and then that's the output stage sorted. Simply all we have to do then is the power into the TDA2822M. Let's grab a piece of wire, and we want to go from about there across to, so we'll trim that to be the correct length. Now before I solder those into place, I'm going to do the capacitor for the voltage in on pin 2. So it is a 10 microfarad capacitor that we need. I'm just happy to have one here. And we are basically going from the voltage in pin 2 to ground. So what I'm going to do is I'm just going to do it straight between pin 2 and pin 4, because pin 4 is ground. So I shall solder that capacitor on now. Now I have to be careful here because I'm very close to those resistors and I don't want to have to solder those back on. There we go. And that's a simple case of connecting a wire from there to the voltage out pin, which I do believe is the middle pin of the LM317, and then we will have power to the TDA2822M. We'll get that soldered into place now. Now, let's ground these capacitors. To go after the resistor, so like so. And there we go. So we've got power connected up. We have the decoupling capacitor. I think that's everything, and it's now more or less time to test. I just need to get 2 wires set up for the ground of the speakers. Now we just need to solder these 2 ground wires for the speaker to the ground rail. Like this. And we are almost ready to test this out. I will get this connected up to the bench power supply and connected to some speakers, and then we'll connect something to the inputs. Okay, so this is going to be the very first test of this amplifier. I've got it plugged into an MP3 player. Flick it on. Play. And there we go. It is actually working first time round. The potentiometer is not very good. It's probably a linear one as opposed to a logarithmic one. However, the circuit works. Let's double check that it's not getting too hot or anything. To be honest, guys, I'm actually really impressed that nothing messed up and it worked first time round, because this is actually part of another project that we're doing. Give this video a thumbs up. Remember to comment, share it, subscribe. I'll see you in part 2 of the video, guys.